Okay, so let's try the next coding exercise. So open the leetcode.com and click on the problems tab. And if you scroll down, there is a problem number 2. Like add two numbers, and it's come in the medium category. But I believe it's easy. It's not a medium if we have some concepts clear. So let's click on it. So let's read the question. Also, let me remove this code. Yeah. So let's read the question. You are given in two non-empty linked list. So one list L1 is given, one list L2 is given. All right. Representing two non-negative integers. All right. So the digits are stored in a reverse order, and each of their nodes contain a single digit. So it means generally we have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So from starting from 10, there are two digit numbers. But it is mentioned in the nodes, it contains only single digit numbers. Right. So we have two lists given, 2, 4, 3, and the 5, 6, 4. Right. So it is mentioned the digits are stored in the reverse order. So reverse order means like actual the number is 342, actual the number is 465. Uh, like generally, or you can say like when we have some two list given. So as an example, let me show you. So when we have two number given, let's suppose I have to add 1, 2, 3 with the 2, 3, 4. How we do the calculation? How we do the calculation? So we started from the end only, right? We started from the end, like 4 and 3, 7. So we started from the end only. But it is mentioned the digits are stored in the reverse order. Reverse order means it's already in the reverse order. So first we have to add 2 plus 1, 3. So we have to start do the addition from the starting only. Okay, because the digits are stored in the reverse order, so we have to do the addition in the starting only. So 5 plus 2 7, 6 plus 4 10, and 3 plus 4 8. Okay, so let's see on the whiteboard. So we have two. So this is the example number 1. So this is the example number 1, right? And this is example number 2. So we have, so let me put this. Yeah. So we have two lists given, 2 4 3 5 6 4. So L1 is pointing to this head, and L2 is pointing to this head. This is L2. All right. And we know we have to add. So 5 plus 2 7, 6 plus 4 10. But in the question uh, it is mentioned that there is a each of their nodes contain a single digit. So we can't store the 10 in a node. So what we have to do is we have to store the 0, and we have to take the carry as a 1. So we will take a carry as a 1. Then 4 plus 3 plus 1 is equal to 8. So the our output should be 7, 0, and 8. So in this example, so both the two lists are of same length. So let's see the another example. So another example, on the right hand side, so 9, 9, 9, 9. So for first list of length 4, the second list of 9 and 8. So let's try to add. So 9, 9, 18, 8, and the carry is 1. 9, 9, 8, 9, 8, 17, and 1, 18, 8, and carry is 1. 9 and 1, 10, and there is no element in the second list. So 9 and 1, 10, 0, and carry a 1. So 9 and 1, 10, so 0 and carry 1. So even the linked list finish. So the highest length is 4, but we get the length of 5. So we have to think in such a way how we can do the addition. So it's a very normal addition, how you just normally do the sum a plus b is equal to c. Very normal addition. So what we have to do is we will because we have to generate one output. So we have to generate one output, and that output is a linked list. So we have to take some linked list, empty linked list. All right, so let's try to take the empty linked list. So L1 is given, L2 is given. So let's take the empty linked list. And how to net the empty linked list node. Okay, so that is done. All right. So now we take the empty linked list and which will be our output. Okay. Now we know L1 is pointing to 2, L2 is pointing, L1 is pointing to 2, L2 is pointing to 5, and we have to add 2 plus 5. So we have to traverse L1 and L2 parallelly. All right. So we have to traverse parallelly. So while L1 and L2, or you can say while L1 is not null or L2 is not null, or while L1 and L2. So while L1 and L2, so what we have to do? We have to do this sum. But which sum? So L1 dot value, because like the value is stored in the val variable. So we are traversing. So L1 dot value plus L2 dot value. All right. Then 5 plus 2, 7. Okay, done. Then whatever the result will come. So let's suppose, okay, this is even not correct. So let's suppose whatever the result will come, we are going to store. And in which node we have to store? We have taken one linked list. So in the next node, this is the L3. This is our L3. This is our L3. So L3 dot next, and we are going to store the 7. So we are going to store the 7. But 7 is a number. 7 is not a linked list. So 7 is not a node. So first we have to create a node. All right. So we have to create a node. So how to create a node? So let me show you. And so temp sum is equal to L1 dot value plus L2 dot value. And we have to do L3 dot next. In L3 dot next, what we have to do? List node of temp sum. So this code is wrong, but we are taking as an first step. So like then we are going to modify. So we have to traverse from L1 and L2. Then what we do, we will just adding it. We have temp sum, then 5 plus 2 is equal to 7. And then L3 dot next is equal to, and L3 is the like our output. And L3 dot next is equal to like the node 7, because 7 is a number, this is a number. So we have to create a node, and create the node with value 7. So we are passing the value temp sum. Then we will proceed our L1 pointer. So now our L1 pointer will here and L2 pointer will here, right? So we are going to like L1 is equal to L1 dot next. Sorry, L1 is equal to L1 dot next. L2 is equal to L2 dot next, and L3 is equal to L3 dot next. Because earlier L3 is this, right? Now we have stored the 7, so now L3 will be this. All right, so L3 will point to this element. So uh, this element which I highlighted. So this element, this 7. So that's why we do L3 is equal to L3 dot next. Okay. Then it will check again whether L1 and L2 is still like none or not. So L1 L2 is not none. Okay. Then what it will do? L1 dot val plus L2 dot val. So 6 plus 4, 10. Temp sum. And it is creating a node, list node of 10. But we know we can't store the 10. So what we have to do? We can take a like how you can take like I like we are getting 10 here, but we know we have to store only single digit. Even if we're going to store like this only, our code is finished, that's it. Even if you're going to store, then our output will be 7 10 7. But we don't need the our output 7 10 7. We need the output as 708. So we need some carry as well. And we need, so we are getting output as a 10, 6 plus 4 10. So how we going to generate a 0 and 1? So how we are going to separate? So what we can do is we can divide, we can take it like we can divide by 10, and we can take a remainder as well. So to do the both the operation, we have dim mode function. So if you search here dim mode Python, so we have a dim mode function in the Python. What it will do, it will give you the like quotient and the remainder, and the same thing we need. Or you can do manually, or you can do the dim mode. So what we have to do, it will give us the quotient, it will give us the remainder, and we have to use a dim mode function, and we don't need to import from the math module, it is the inbuilt function. And it will take two argument temp sum, that is the like the divisor and the dividend. So if you see here, it will take the numerator and the denominator. So denominator is like our sum, and denominator is 10. It will take the quotient and the remainder, because we have to store only 0. All right. So remainder is 0 and quotient is 1, and 1 will be the carry. So either you can say quotient or either you can say carry. Either you can say carry or either you can say quotient. So carry is equal to carry and remainder demode. So we have to store the remainder here. Because we have to create a node with the remainder, that is the 0. 0 is the remainder, right? If you divide 10 by 10, the remainder is 0 and the carry is 1. Quotient is 1, so that is the carry. Or you can do quotient and then you can do carry is equal to quotient. Or just to give some standard names, we can do carry. Okay, we are getting carry and the remainder because it is going to return the tuple. So that's why we are getting carry and the remainder. Within the same function, within one line of code, we are getting both the quotient and the remainder. Instead of writing two lines, like one line is for the divide, one line is for the modulus operator. So we are doing this. So we have to store the remainder. That is a single digit. Even if we get 5 plus 2, 7. So 7, uh, and if we pass the mode function 7 comma 10, then carry is 0, remainder is 7. So that is fine. Instead of directly storing the temp sum, if we store the remainder, then remainder will be 7. For this as well, 5 plus 2, 7, then remainder is 7 only. So which is perfectly fine. Okay. Then we are getting 4 plus is equal to 10. Fine. Okay. And we are storing 0. Okay, fine. And we are storing carry into 1 into carry, which is fine. Now our L1 pointer points to the now our L1 pointer points to the this and L2 pointer point to the this node. Now 3 plus 4 is equal to 7. Right? Because L1 plus value plus L2 dot value 7. But where is the carry? How the carry is going to add? So that's why we need the carry here. Plus carry, and we will take in starting carry is equal to 0. All right, so because in carry 0, because 5 plus 2 plus 0 7, 6 plus 4 plus 0 10. Now 4 plus 3 plus 1, because now carry is 1. Now carry is equal to 1. So that's it. So our code is finished. But this logic is when we have both the list are of same length, like a 2 4 3 5 6 4. All right. And there could be chances, let's suppose here instead of 3 we have 9. So we will get one more extra element here. So we will need one more node here. So we have to write one more logic here. If carry is greater than 0, then what we have to do, then L3 dot next. So L3 dot next, we have to create a node. Now we have to create a node for the carry value, whatever the carry. If the carry is 1, then it's the node will be 1. If the carry is 2, then the next node will be 2. So here the next node will be 2 or whatever it is, and we are going to connect with this. All right. So L3 dot next is good list node carry. So that is fine. But what about these scenarios when the L1 has more length and well the L2 has length? Because in this case our loop will run only this part, like 9 8 9 8, because we are saying when while L1 and L2, right? So we have to run one more loop. We will check while L1. We will check. We will check while L1. So if L1 is there, we are going to repeat this same thing. Only difference is here now it's only L1. We don't need the L2. So L1 dot value plus carry demode, and then we don't need to do L2 dot next because there is no L2. All right. And if the length of L2 is more, then we have to repeat the same thing while L2, and we have to do L2 dot value and here L2 dot next. All right. And so our code is finished. What we have to return, so we are so first L3 is first L3 is here, right? So then L3 is pointing here, then L3 is pointing here, then L3 is pointing to next. So we will reach at the end, but we have to print the output. So our output should be starting from the 7, because we have to print from the starting node. So what we can do is from the starting we can store its head. So we have stored its head somewhere. So if we store its head, so first is the empty node. So if we normally print a result, then it is going to print 0, 7, because by default value is 0. By default value is 0, the 0, 7. So what we have to do, result dot next, because we have to print from the 7, because otherwise there is an empty node as well. And we started from here 7 to 3. Okay. So what we have to do, we have to return result dot next. So let's try to run this code. I am okay. I have written outside the function. 1 minute. Yeah. So all the three cases have been accepted. So let's try to submit it. So our solution has been accepted. Right. So our solution has been accepted. Uh, which is perfectly correct, and like it has been accepted. But na like if you see, we are unnecessarily repeating a lot of code here. So the code will remain same. Code will remain same. We can save a lot number of lines. So how we are going to save a lot number of lines? So let's delete this. All right. So this will remain same. L3 is equal to list node, result is equal to L3, carry will be 0. The logic will remain same. There is no change in the logic. Only the thing is we are going to remove the some duplicate lines. Even if you don't remove the duplicate line, that is still perfectly okay, which is fine. So why we have the duplicate lines? So because we are running the loop while L1 and L2. If we run the loop while L1 or L2, then we can save the line. So while L1 or L2. So until the L1 is there or L2 is there. Okay, while L1 is equal to L2, then we can do it, we can get the first value. First value is like 9, right? So how we are getting the first value? So L1 dot val. Then we are getting the second. Okay, L1 dot val and L1 dot, and we are getting the second value L2 dot val. All right. Then we have to do the sum, temp sum. And what is the sum? Value 1 plus value 2 plus carry. All right. And then we will like take the remainder and the same thing like which we did last time. So temp sum, comma 10. And we will do the L3 dot next is equal to list node, list node of remainder. And then we will do L1 is equal to L1 dot next, L2 is equal to L2 dot next, and L3 is equal to L3 dot next. So this is the code which we written last time. So let's do something. Yeah. So this is the code which we written last time. Instead of or, we just put instead of or, earlier we are using the and. But we want like within a single loop we want to do this. So till this point, till 9 8 point. So till till this point it is going to work fine. All right. But as soon as it come next, all right. So while L1 or L2, so okay, while L1 or L2, so L1 is there, but L2 is not there. All right, so it is going to get the value of L1. So value 1. What is the value 1? Value 1 is equal to L1 dot value. We will get 9. But value 2, L2 dot value. What is L2 dot value? We have none here. So we will get the none here. All right. So what we have to do, we will get the value if L2. All right, else 0. If L1, else 0, because by default we are giving the 0 value. So that's why we don't need to, we can like save some repetition of the code. So if L1, if L1, then we will get the L1 dot value. Otherwise, because if we don't write this code now, and we will keep the same thing, like just put or here, then we will get L2 dot value as a none. And we are doing none, like 9 plus none plus some carry, which is like we are getting some error because we can't add integer with the none. Right. So that's why we have to do something like this. Like if L1, then we are getting L1 dot value, otherwise 0. If L2, then we are getting the value. Similarly here, we will do the L1 dot next if L1, else none. So if L2, else none. That's it. So our code is finished. But if carry is greater than 0, then we have to do L3 dot next is equal to list node of carry. Okay. And then we have to return a result dot next. So basically we like earlier there are if loop was there, this portion was already there last time, this portion was already there, even this portion was already there. But we are like checking again L1 and L2 because like L1 can be more length, L2 can be like more length. So instead of we can like put here in the if class. So let's try to run it. So our solution has been successful. Let's try to submit it. So now we beat 78% of the people because we decrease some like earlier we beat 45% of the people because there were three while loops. Now there is only one while loop. So that's why like runtime it get decreased. But the logic is same only. So logic is same. We have to traverse both the arrays. We have to add it. We have to find the quotient. We have to find the remainder. We have to create the node. Then we have to create the we will like find that the newly node into the L3, then we are going to increase our L1 pointer, then we are going to increase our L2 pointer, then we are going to increase our L3 pointer. At the end, we will check if the carry is greater than 0, then we will like create one more node for the carry. Let's suppose in this case, in this case, we have the carry. So that's why we are adding the node here. So we will check if the carry is greater than 0, then we are going to create a node and we are attaching that node. So that's it. That's the end of the video. Like it's generally like easy question. I can't say it's a medium question. It's the easy question if we just know the very minimum concept, like how to get the value, how to do the next pointer, how to do the add. Right. So that's the end of the video. You can also try this question. Okay. Thank you.